Hi everybody, I'm Miss Cooksey and today we're going to talk about absolute value inequalities. These are going to be very similar to absolute value equations with one extra step. Let's get started. So here are our steps. We're going to start by isolating the absolute value function. Then we're going to make two inequalities. One that has a positive solution and the same inequality sign, and one that has a negative solution and the flipped inequality sign. This is just like when we were solving equations and we had a positive equation and a negative equation. The same thing, except with we flip the inequality sign for the negative solution. Then we're going to solve each inequality and we're going to graph the solution just for the practice. So we have x plus 1 is less than 4. Well, let's go ahead and solve this. So we have x plus 1 is less than 4 and x plus 1 is greater than negative 4. Subtracting 1 on both sides of the inequality symbol gives us x is less than 3 and x is greater than or equal to negative 5. When we graph this, we have the range of values between negative 5 and 3. In the next one, to isolate absolute value, we have to undo this 3. The 3 is being multiplied, so we're going to divide by 3. And that gives us the absolute value of 2x is greater than 10. Now I'm going to make my two inequalities. One is going to say 2x is greater than 10, the exact same thing. And one says 2x is less than negative 10. Then we're going to divide both sides of the inequality symbol by 2. We have x is greater than 5 and x is less than negative 5. When we graph them, this is an OR inequality because we have the values that are bigger than 5 and less than negative 5. Let's look at this next one. The absolute value of n plus 1 is less than negative 5. Well, we know absolute value is always positive. So that means that there is no number that I can place in for m that will make the value after I apply the absolute value function less than this negative number. Because absolute value cannot be less than a negative number, there is no solution to this equation, or this inequality. Let's go ahead and look at 3 more. We have the absolute value of x minus 2 plus 1 is less than or equal to 7. We're going to start by subtracting 1 on both sides of the inequality sign to isolate absolute value. Then I'm going to make my two inequalities. So, the x apparently disappeared, but they have x minus 2 is less than or equal to 6. Let's get back where we're supposed to be. We're going to add 2 to both sides of the inequality, and x is less than or equal to 8. Then I have x minus 2 is less than or equal to negative 6. I'm going to add 2 to both sides of my inequality, and x is greater than or equal to negative 4. I'm going to graph, and I have the range of values between negative 4 and 8. 2 more. I'm going to divide both sides of my inequality symbol by negative 2. I'm going to make 2 equations and solve. So I have x is greater than or equal to 1.5. X is less than or equal to negative 0.5. Notice that I have my positive value, my negative value, and I switched my inequality sign. I'm going to graph these, and I have an OR inequality, so less than negative 0.5, greater than 1.5. And for my last inequality, I have the absolute value of x minus 7 is greater than or equal to negative 5. Here, absolute value, because when we apply absolute value, it always makes everything positive. No matter what x is, it's going to be positive. And the positive number is always bigger than the negative number. So the answer here would be infinite solutions or all real numbers. Thanks for watching. I hope this video was helpful. Make sure you hit subscribe so you never miss a video, and I'll see you next time.